Hello everyone, Smriti this side, TGT Science from SR International School. And the chapter that we're going to study today is Separation of Substances. Now when we talk of separation of substances, we must be aware that substances can be categorized into two types. Number one is a pure substance and number two are mixtures. Pure substances are the substances which are made up of the same kind of particles, for example, oxygen, nitrogen, hydrogen. Whereas when we talk of mixtures can be defined as substances which are made up of more than one kind of particles. They can be a mixture of salt and water, it can be a mixture of iron fillings and sulfur, etc. When we talk of mixtures, as I said, it's a combination of more than one kind of particles. Therefore, mixtures can be divided into two parts. Number one are homogeneous mixtures. Homogeneous mixtures are those mixtures which dissolve completely, which maintain a uniformity. For example, sugar and salt, when you combine them both, they mix completely. They maintain a uniformity. Therefore, they will be termed as homogeneous solutions. Number two are heterogeneous mixtures. Heterogeneous mixtures are the mixtures which cannot be combined and make a uniformity. They are non-uniform in nature. For example, you take iron fillings and you take sulfur. You try mixing both. They won't be mixed. And therefore, they can be separated by physical means. Now we are talking about separation of substances. So also the question arises that why separation is required? Why do we need to separate? Number one, to obtain the pure substances. Number two, to discard the waste, the useless and the not so useful substances. And number three, to get pure substances from for our own use, to obtain the useful components. So therefore, that's why we need to separate various substances. Now there are certain ways of separation. Let's read about them.
Once the crop gets matured or ripen, it has to be gathered. The process of cutting and gathering a matured crop is known as harvesting. Harvesting is done in 3 steps. 1. Cutting the crop. 2. Separating grain from stalks and 3. Removing chaff from grains. Harvesting can be done manually as well as with the help of machines. Let's see how crops are cut. Crop can be cut manually by using handheld tool called a sickle. In big farms, a large vehicle called harvester is used for cutting the crop. Harvesters save lot of time and labor. Next step is separating grains from stalk. This process is known as threshing. Manual threshing is done by beating the stalk against hard surface. Machines such as thresher are also used, which are very efficient. Some machines do both the parts of cutting and threshing together. These machines are called harvester combine. After threshing, grain obtained is mixed with remains of chaff and husk. Clean grains are obtained by winnowing. Winnowing can be done manually as well as there are machines which perform winnowing task very fast. After harvesting, grains can be sold for economic.
Sieving. Sometimes we may wish to prepare a dish with flour. We need to remove impurities and bran that may be present in it. What do? We use a sieve and pour the flour into it. Sieving allows the fine flour particles to pass through the holes in the sieve, while the bigger impurities remain on the sieve. In a flour mill, impurities like husk and stones are removed from wheat before grinding it. Usually, a bagful of wheat is poured on a slanting sieve. The sieving removes pieces of stones, stalk, and husk that may still remain with wheat after threshing and winnowing.
Study The process of sedimentation and loading. Things required: 4 glass tumblers, water, sand, clay, a glass or wooden rod, and some amount of alum. Procedure: half fill 3 glass tumblers with clear water and mark them as A, B, and C. Add some sand to the water in tumbler A and stir well with the help of a rod. Add some clay to the water in the tumbler B and C and stir them as well. Let all the 3 tumblers stand undisturbed for a few minutes. You will observe that the particles of sand settle very quickly and the water in tumbler A becomes clear, while the water in tumblers B and C still remains muddy. Now, take some clear water in the 4th glass tumbler. Take a little amount of alum and dissolve it in the water taken in the 4th glass tumbler to prepare alum solution. Stir the glass tumblers once again with the glass rod. Add some amount of alum solution to the water in tumbler C and stir it gently for a few seconds. Leave all the 3 tumblers once again undisturbed for some time. On observing the tumbler, after some time we find that in tumbler A, sand particles are the first one to settle down at the bottom. The clay particles in tumbler C becomes larger and starts settling down faster than before, and the water layer in this tumbler also becomes clear. However, in the tumbler B, the clay particles do not settle and the water is still muddy. This activity shows that sand particles in the mixture of water settle down earlier, thus making water layer clear. On adding alum to the mixture of clay and water, the process of sedimentation is accelerated.
I need to remove this nail polish. Nail polish can be removed by acetone. Acetone can be obtained by simple distillation.
The process of heating a liquid mixture to form vapor and then cooling that vapor to get a liquid is called simple distillation. Distillation is used to purify a liquid by separating the components of a liquid mixture. Let us perform an activity to understand simple distillation. Take a mixture of acetone and water in a distillation flask. put a thermometer in it. Connect the flask to a water condenser. The condenser has cold water running through its jacket to keep the temperature cool. Keep a beaker at the outlet of the condenser. Heat the mixture, keeping an eye on the thermometer. When the temperature hits 56 degrees Celsius, acetone starts to vaporize. These vapors condense in the water condenser. The condensed acetone gets collected in the beaker. When all the acetone vaporizes, water is left in the flask. Acetone is collected in the beaker. In this way, acetone and water get separated by simple distillation. Boiling point of water is 100 degrees Celsius. Boiling point of acetone is 56 degrees Celsius. As there is sufficient difference between their boiling points, these components can be separated by simple distillation. Simple distillation does not work properly when difference between two boiling points is less than 25 degrees Celsius. This is because the components do not get separated and purified completely. If we repeat this process multiple times, we will be able to separate these two components. However, as this is very time-consuming, a special type of distillation called fractional distillation is used.
When we have a mixture of salt in water to separate, we take this solution in a kettle and cover it with a lid. Now gently heat the kettle for some time. Heating transforms water into vapor that escapes from the spout of kettle. Continue heating till all the water gets converted into vapor and only salt is left behind in the kettle. Thus, salt dissolved in water can be separated from the water through this process. This process of conversion of water into vapor by heating is called evaporation. In order to obtain the water while heating the salt water, hold a plate containing ice just above the spout of the kettle. When the steam escaping through the spout comes in contact with the plate containing ice, it condenses and forms water. This process gives us back the water. This process of conversion of water vapor into water is called condensation.
Filtration. Take a round filter paper and fold it into halves to make a cone as shown here. Fix a funnel on a stand. Wet its side and keep the filter paper in the funnel. Pour muddy water through the filter paper. Clear water will be collected in the beaker below the funnel. The clear water obtained is called the filtrate. This method of purifying water is called filtration.
Solutions like sugar in water has two components. The two components of solutions are solute and solvent. Solute is a substance that dissolves in solution. It is usually present in small amounts. In this mixture, the solute is sugar because sugar dissolves in solution and is usually present in small amounts. Now, let's talk about the solvent. Solvent is a substance that dissolves a solute. It is usually present in greater amount. The solvent in this solution is water because water dissolves sugar and is usually present in greater amounts. Between solute and solvent, we will focus on the solute. The ability of solute to dissolve in solvent is what we call solubility. Solubility is a maximum amount of solute that can dissolve in a given amount of solvent at a certain temperature. The amount of dissolved solute produces three types of solutions. Here's an experiment about the three types of solutions based on the amount of dissolved solute in solvent. Unsaturated solution is a solution that contains less solute than the maximum amount the solvent can dissolve at a given temperature. Its color is lighter than saturated and supersaturated solutions. Saturated solutions is a solution that contains the maximum amount of solute dissolved by a given amount of solvent. The color of saturated solution is intermediate between unsaturated and supersaturated solutions. Supersaturated solution is a solution that contains more solute than the maximum amount the solvent can dissolve at a given temperature. Its color is darker than unsaturated and saturated solutions. It has an excess solute or sugar which can no longer dissolve. Let us sum up. The three types of solutions are unsaturated, saturated, and supersaturated solutions. Unsaturated solution is a solution that contains less solute than the maximum amount the solvent can dissolve at a given temperature. Saturated solutions is a solution that contains the maximum amount of solute dissolved by a given amount of solvent. Supersaturated solution is a solution that contains more solute than the maximum amount the solvent can dissolve at a given temperature. The color of unsaturated solution is lighter than saturated and supersaturated solutions. The color of saturated solution, on the other hand, is intermediate between